1G, slope of a straightened graph. Recall from lesson 1F, we graphed the data of the effect of different masses on the rate of which a spring oscillates. Heavier masses create a longer oscillation cycle. When we graphed it, we noticed that the time versus mass was a root relationship, based on the curve alone. When we looked at the equation for a root function and compared it to the equation of a linear function, we noticed the only real difference was the value of x. In the curved line equation, it was root x, while in the linear function, it was simply x. So simply by substituting root x for x, we rewrote the equation for the linear function as y equals m root x plus b. So using this equation, we manipulated the x values while keeping our y values. And when we graph this new data, we can see the graph is linear. When plugged into Excel, the r squared value is 0.99671, which makes it likely that it is linear. Now that we have a straight line, we love using our Math 9 skills to calculate slope. But what does it give us? Well, if we revisit our manipulated equation for the straight line, y equals m root x plus b, slope gives us the value for m. Now for slope to represent m, it needs to have certain units. Recall y equals time and x equals mass. So time is in seconds equals the slope times root of mass in kilograms plus b. In order for m times root x to give us time in seconds, m must have the units seconds over square root kilogram, so that when it's multiplied by root mass in kilograms, it cancels out simply to leave us with time in seconds. Let's look at our manipulated graph and determine if it does give us seconds over root kilogram when calculating slope. Slope is rise over run, or y values over x values. Y values are in seconds, while x values are in root kilograms. Slope does give us the correct units. If we can identify the type of curve graph we have and make it a linear function, we can calculate slope and look for the y-intercept to determine the equation for the relationship. So let's go ahead and calculate the slope and then calculate the equation. Slope is simply rise over run. To do so, you must choose 2 points on the line, not just any 2 points. If your line of best fit does not pass through 2 points, you must estimate the value of 2 points that are on the line. I will choose 0, 0 and 0.55, 1.16, which are 2 points that live on the line. Slope is rise over run, or more formally, change in y over change in x. Shorthand is delta y over delta x, and more correctly, y2 minus y1 over x2 minus x1. Using the 2 coordinate points that we chose earlier, we can substitute delta y as 1.16 minus 0, and delta x is 0.55 minus 0. The top units are in seconds, the bottom units are in root kilograms. Using our calculator, we calculate the slope to be 2.07 seconds per root kilogram. So revisiting our equation, time equals slope times root of mass plus b. We can substitute now our slope. Time in seconds equals 2.07 seconds per root kilogram times square root of mass in kilograms plus 0. Our equation is time in seconds equals 2.07 seconds per root kilogram times root mass in kilograms. Our equation simplified is t equals 2.07 m to the power of 1/2, which is equivalent to square root m, where m is mass.